Good morning, students. Today's topic is graphs and hashing. Okay, and the last unit is 3. Overall unit we discussed about the trees, but in this unit we are discussing about graphs and hashing. First part only discussing about the graphs, and second part is hashing. Okay, and then graph means what is meant by graph. Define graph. What are the terminologies we are using in that graph? What are the terminologies we are using in that graph? Okay, here graphs. A graph is a subset of G equal to V comma E. That means a graph is a combination of vertex and edges. Here, a graph consists of a finite non-empty set of vertex denoted by V, and also called as a nodes. That vertices are also called as a nodes, and finite set of edges, E. Edges are denoted by E and also called as a arcs. Okay, a graph consists of a finite non-empty sets of vertex denoted by V and also called as nodes, and finite set of edges denoted by E are also called as arcs. Okay, simple example for graph here: A, B, C, D. These four are vertices. A, B, C, D are vertices, and also called A is also one node, B node, C node, D node. Okay, vertex are also called as a node. So here V is denoted by vertex. Okay, A comma B comma C D. Okay, E, edges. Edges are denoted by E and also called as arcs. Edges are also called as a arc. E1, E2, E3, E4, E5. Overall, how many edges is there? E1, E2, E3, E4, E5. Okay, and then E1 edge. Okay, two vertex can be joined by one arc. That arc is called as edge. Okay, arc. So here E1. E1 indicates A comma B. E2 indicates A comma C. E3 indicates C comma B. And then E4 indicates C comma D. E5 indicates B comma D. Like that. Okay. That is graph. A graph consists of a finite non-empty set of vertices, also called as nodes, and finite set of edges, also called as arcs. A graph is a finite set of non-empty set of vertex and edges. Okay, and then here graph terminologies. What are the terminologies we are using in graph? Especially here digraph. Digraph is nothing but directed graph. Digraph are also called as directed graph. Digraph are also known as directed graph. A graph in which every edge is directed. Edge is nothing but arc can be directed is called as a digraph. A digraph is also known as directed graph. Okay, digraph symbol, just edge and a line draw. When you are giving the arrow mark, this is a directed graph. Okay, here simple example: A, B, C, D are vertices. For joining purpose we are using the edges, arcs. Okay, that arcs giving line and then giving some arrow mark to that line is called as a directed graph, like this. Okay, and then vertex are A, B, C, D, E1, E2, E3, 4. E1 having the directions, what the directions say? A, B. E2 having AC. E4, E3 having CB, BC or CB, whatever it may be. E4 having CD. Okay, like this. And then next one, undirected graph. A graph in which every edge is undirected. Here every edge is directed. Here every edge is undirected. Then it is called as an undirected graph. Edge. Here Vi, Vj is equivalent to Vi, Vj, Vi. Vice versa. Vi, Vj, vertex I, vertex j is equivalent to vertex j, vertex I. Example here, A, B, C, D are 3 vertices and then edges are E1, E2, E3. E1 having A, B, E2, AC, E3, CB. But there is no any direction, arrow mark is not there, so it is the undirected graph. Whenever here having the any arrow mark, then it is called as a directed graph. There is no arrow mark here edge, no, so it is a undirected graph. Okay, and then mixed graph, a graph in which some edges are directed, some edges are directed, some edges are undirected, both are having in simple graph, then it is called as a mixed graph. Okay, here some example, then here A, B, C, D are vertices and then edges are E1, E2, E3, E4, and then here A, B having undirected, A, D having undirected, but E2, E3 edges are directed. Why? Because they are giving some direction, arrow mark. So these two are directed, these are undirected. Both we have, then this graph is called as a mixed graph. Okay, then E1, A comma B. Whenever you are having the undirected graph, then you are indicate like a round. Directed means square, angular brackets, angular brackets. Here E2 is a directed graph, so angular brackets of A comma C, and then E3 is a directed graph also, so direction is there, so angular bracket of C comma D. E4 having does not having any direction, so A comma D with brace, round braces. Okay, weighted graph. Next one is weighted. A graph is termed as a weighted graph if all the edges having some values, then it is called as a weighted graph. Instead of E1, E2, E3, E4 in the graph having here any values, then it is called as a weighted graph, like this. A, B, C, D are vertices. So these are also A is a node, B is a node, C is a node, D is a node. But here having some weight, AB having some weight. What that weight? Y, 5. AC having 7. AD having 3. CD having 9. Then it is called as a weighted graph. Okay. Next one, adjacent vertices. A VI is a adjacent neighbor of another vertex. Adjacent means besides. So VI having the adjacent to VJ. That means A adjacent to B. Here's some edge. So adjacent vertices are having. Okay. If there is an edge from VI to VJ, there is an edge between VI to VJ, VI to VJ, then is a adjacent vertex. Self loop. Suppose this one is a one vertex, this one is a one node. Here the starting point, here the ending point. Then it is a self loop. Here starting here, ending here. But here starting A is the starting, B is the ending. This is not a self loop. Okay. Self means starting and then ending at the same point, then it is called as a self loop. Here A, B, C. Here A having the self loop, C have the self loop. Okay, E1, E2, E3, E4, E5. Okay, then it is self loop. Starting and ending at the same position, then it is called as a self loop. If there is an edge where starting and ending vertex are same, starting and ending vertex same. Here starting is A, ending also A. Here starting is A, ending is B. It's not a self loop, it's a self loop. Okay. Then in degree of vertex, number of edges coming into the vertex. Out degree means number of edges coming into the vertex is a in degree. Number of edges out from a vertex is a out degree. ఒక వర్టెక్స్ లోకి ఎన్ని ఇన్ అవుతున్నాయి దాన్ని ఇన్ డిగ్రీ, ఒక వర్టెక్స్ నుంచి ఎన్ని అవుట్ అవుతున్నాయో దాన్ని అవుట్ డిగ్రీ అంటారు. సో డిగ్రీ ఆఫ్ ది వర్టెక్స్, హౌ టు ఫైండ్ అవుట్ ది డిగ్రీ ఆఫ్ వర్టెక్స్ మీన్స్ సమ్ ఆఫ్ అవుట్ and sum of in degree, sum of out and sum of in degree. Here simple graph I take A, B, C, D. Here the vertex are A, B, C, D and also nodes A, B. Here I given the directed graph. Why? Because I given the edge as a arrow mark, then it is called as a directed graph. Here in this direction we have to find out the sum in degree and out degree. Here suppose I take one of the vertex here A. A degree of vertex of A ఫైండ్ అవుట్ చేశానంటే డిగ్రీ ఆఫ్ వర్టెక్స్ ఆఫ్ ఏకి ఫైండ్ అవుట్ చేయండి. ఏ నుంచి ఎన్ని అవుట్ వెళ్తున్నాయి? బి, సి. అవుట్ కనెక్షన్కి ఏమేమి వెళ్తున్నాయి? బీకి, డీకి. అంటే ఎన్ని నోట్స్కి వెళ్తున్నాయి? 2 నోట్స్ అవుట్. ఇన్ డిగ్రీ ఏ నుంచి ఏకి ఏవి ఇన్ అవుతున్నాయి అంటే సి నుంచి ఏకి ఒకటే వస్తుంది. సో 1 ఇన్ డిగ్రీ ఈజ్ 1, అవుట్ డిగ్రీ ఈజ్ 2. సో 2 + 1 3. ఓకే, లైక్ దట్. Here also you have to find out the D. Suppose degree of vertex of D. In degree ఎంతండి? In degree 1. Both are in degrees. A నుంచి Dకి వస్తుంది, C నుంచి Dకి వెళ్తుంది. సో in degree ఉంది కానీ out degree ఉందా? లేదు. Suppose I give the connection like this. Then out degree is only 1. Okay. Out is 1. In is 2. In or? సో అవుట్ ఈజ్ 1 మీన్స్ బి, ఇన్ ఈజ్ ఏ నుంచి వస్తుంది, సి నుంచి వస్తుంది. సో డిగ్రీ ఈజ్ 2 + 1 3. నెక్స్ట్ పాత్. A path from vertex Vi to Vj is a sequence of vertices. Sequence means V1, V2, V3, V4, V5. Like that only V0, V1, Vi, Vi + 1, Vi + 2. Like that up to Vj. Okay, that all are vertex. Edges are Vi, Vi + 1, Vi + 1, Vi + 2. Pairs, like a pair. Like that V1, V2, V3, V4, like that. The length of the path is the number of edges in it. How to find out the path length means it depends upon the edges. It depends upon the edges. Like here 1, 2, 3, 4 vertices. Then how many edges is there? 1, 2, 3, 4. The length of the path is also 4. Here V1 to V4 path. Which way? V1, V2, V3, V4. Like that. Next path in the V1, V3, V4. Okay. How many possibilities? Like that we have to find out the path. Complete graph. Next one is complete graph. A graph is said to be a complete graph when if each vertex Vi is adjacent to the other vertex Vj, then that graph is called as a complete graph. Suppose here how many vertices are there? 1, 2, 3, 4. Overall all vertices having connection, then it is called as a complete graph. Here like this A, B, C, D. Here this is one vertex, this is one vertex. Vertex are also nodes. Every vertex having the connection. Okay, then here A to D, A to B, like this. This is a complete graph? No. Diagonals also have to be filled. Like this. That all connections can be there. Then it is also a complete graph. Adjacent to each other. ప్రతి వర్టెక్స్ కూడా ఇంకో వర్టెక్స్కి అడ్జసెంట్ అయ్యాలి. అడ్జసెంట్ ఎప్పుడు అవుతుంది? మనం ఎడ్జ్ అనేది ప్రొవైడ్ చేసినప్పుడే. సో దాన్ ఇట్ ఈస్ కాల్డ్ యాజ్ ఎ కంప్లీట్ గ్రాఫ్. ఓకే. కనెక్టెడ్ గ్రాఫ్. Two vertices Vi to, if two vertices Vi to Vj are connected, if there is a path in G is nothing but graph and from Vi to Vj, then it is a connected graph. Okay, two vertices having, suppose here you have to take one A and then B, you have to connect between A and B. Which way you have to connect? By giving the arc is nothing but edge, then it is called as a connected graph. Okay, next one is undirected graph. Undirected graph is said to be a connected graph. Undirected graph also said to be a connected graph. Undirected is said to be a unconnected graph in which pair of distanced vertices Vi to Vj are connected. all vertices to be connected, distance vertices are connected, then it is called as a undirected graph. Here how many vertices? 1 2 3 4, all vertices having the connection, then it is as a undirected graph. A digraph is said to be a strongly connected graph. A digraph is strongly connected. Digraph is nothing but డైరెక్టెడ్ గ్రాఫ్. దాన్ని కూడా మనం ఏమనొచ్చు? స్ట్రాంగ్లీ కనెక్టెడ్ గ్రాఫ్ అనొచ్చు. ఎలా? ఇన్ విచ్ టైమ్? వర్టెక్సెస్ విఐ విజే గ్రాఫ్లో, ఇన్ ఏ గ్రాఫ్ విఐ విజే దెర్ ఈజ్ ఎ డైరెక్టెడ్ ఫ్రమ్ విఐ టు విజే అండ్ ఆల్సో ఫ్రమ్ విజే టు విఏ. దట్ మీన్స్ హియర్ ఏ బి సి డి హ్యావింగ్ directed means arrow mark. ఈచ్ అండ్ ఎవ్రీ వర్టెక్సెస్ కూడా కంపల్సరీగా ఉంటాయి. సో ఏ నుంచి బీకి ఉంది, బి నుంచి సికి ఉంది, డి నుంచి ఉంది, బట్ కనెక్షన్ బిట్వీన్ బీడి కనెక్షన్ ఉందా? లేదు. సో కనెక్షన్ ప్రొవైడ్ చేస్తే దాన్ని ఇది స్ట్రాంగ్లీ కనెక్టెడ్ గ్రాఫ్ అని అంటాం. ఓకే, ఏ పెయిర్ ఆఫ్ డిస్టెన్స్ వర్టెక్సెస్ విఐ టు విజే, విజే టు విఐ, అన్ని వర్టెక్సెస్కి కనెక్షన్ ఉంటే దాన్ని ఈజ్ డైరెక్టెడ్ గ్రాఫ్. digraph. Cyclic graph, acyclic, not cyclic, there is no gap at all here. Acyclic, ACYCLIC, acyclic graph, if path containing one or more edges which starts VI and terminates in the same vertex is called cyclic. Okay, if suppose యాక్చువల్గా అసైక్లిక్ గ్రాఫ్ గురించి డిస్కస్ చేసే ముందు సైక్లిక్ గ్రాఫ్ అంటే ఏంటో డిస్కస్ చేస్తాం. ఏంటంటే సైక్లిక్ గ్రాఫ్ అంటే వన్ ఆర్ మోర్ ఎడ్జెస్ విచ్ స్టార్ట్స్ పిఐ అండ్ టెర్మినేట్స్ ఇన్ టు ది సేమ్. అంటే సపోజ్ సర్కిల్ అంటే ఎలా అంటుంది? ABCD స్టార్టింగ్ పాయింట్ ఇదండి, ఇలా కంటిన్యూ అవుతుంది, ఎండింగ్ కూడా ఎక్కడ అవుతుందండి? ఇక్కడ ఎండ్ అవుతుంది. అంటే స్టార్టింగ్ ఇక్కడ నుంచి అయింది, సో యారో మార్క్ ఇద్దాం, ఎండ్ ఇక్కడ అంటే స్టార్టింగ్ పాయింట్ ఏనే, ఎండింగ్ పాయింట్ ఏనే. సో దెన్ ఇట్ ఈస్ ఏ సైకిల్ గ్రాఫ్. అసైక్లిక్ అంటే ఏంది? ఇఫ్ ఏ గ్రాఫ్ డస్ నాట్ హ్యావ్ ఎనీ సైకిల్ దెన్ ఇట్ ఈస్ కాల్డ్ యాజ్ ఏ అసైక్లిక్ గ్రాఫ్. ఇట్ సపోజ్ సేమ్ పాయింట్లో కాకుండా అనదర్ పాయింట్లో ఎండ్ అయితే దాన్ని అసైక్లిక్ గ్రాఫ్ అంటారు. సో లైక్ దిస్ హియర్, సపోజ్ హియర్ స్టార్టింగ్ ఇక్కడ నుంచి స్టార్ట్ అయిందండి. సో స్టార్టింగ్ అయింది, ఇక్కడ నుంచి స్టార్ట్ అయింది, ఇట్లా వెళ్ళింది, మళ్ళీ అగైన్ వే అనేది డిఫరెంట్ వేస్లో ఎడ్జెస్ డైరెక్షన్ అనేది ప్రొవైడ్ చేస్తాం. సో దిస్ ఈజ్ a cyclic గ్రాఫ్. దెర్ ఈజ్ నో సైక్లింగ్, అంటే సమ్ సర్క్యులర్ ఫామ్లో వెళ్ళే సైక్లింగ్ అయితే ఇక్కడ డైరెక్షన్ లేదు. సో డైరెక్షన్స్ ఆర్ డిఫరెంట్, దెన్ ఇట్ ఈస్ కాల్డ్ యాజ్ ఏ అసైక్లిక్. ఇఫ్ ఏ గ్రాఫ్ డస్ నాట్ హ్యావ్ ఎనీ సైకిల్ దెన్ ఇట్ ఈస్ కాల్డ్ యాజ్ ఏ అసైక్లిక్ గ్రాఫ్. Okay, subgraph. Okay, a subgraph is nothing but already you have some graph. In that graph I have there is another graph, means then it is a subgraph. A subgraph is G, a graph is G dash. I denoted like this, G dash. Then such that vertex of G dash is a subset of V of G. Okay, edge also like this. E of G dash is a subset of E of G. Okay, here for example 0 1 2 3 4, this is a graph, undirected graph. There is no directions at all in this graph. There is a complete graph also. So this is a directed graph, undirected graph. Here suppose I draw how many vertices? 1 2 3 4. Suppose I draw one of the part in this 0 1 2 like this. This is a subgraph. So this is a graph, this is a subgraph. This I indicate as a G. This one is a G dash. G dash is a subset of G. Okay, like this. As well as in tree also we having the root node, and in root node are having some parent nodes having child nodes again having the parent, like that also here also graph. This is a subgraph 0 1 2, and again you have to form another subgraph also like this. Which way? 0, 1, 3, like this, giving the connection way between 3 vertices. Then it is also one of the subgraph. Okay, I define this graph is a G dash, this is a G. Here vertex and edges also copied from original graph, then it is a this one is a subset of this graph. Okay, G dash is a subset of G, that is a subgraph. These are all are the introduction of graph. Okay, thank you students.